In the annals of scientific history, few moments shine as brightly as the day Ernest Rutherford split the atom. This groundbreaking achievement in 1917 transformed our understanding of the universe. Rutherford's work marked the dawn of nuclear physics and heralded an era of scientific and technological advancements. Before his work, the atom was thought to be indivisible, an unbreakable building block of matter. Rutherford's experiment proved otherwise, showing that atoms could be split into smaller particles. The implications of splitting the atom were profound, leading to both the creation of nuclear energy and the development of atomic weapons. As we delve into the story of Rutherford's groundbreaking experiment, we will explore the scientific context, the details of the experiment, and its far-reaching impact. At the turn of the 20th century, the scientific community was grappling with the mystery of atomic structure. Among the prevailing theories was J.J. Thomson's plum pudding model, depicting the atom as a sphere of positive charge with negatively charged electrons scattered throughout. This model was widely accepted but left many questions unanswered. Ernest Rutherford, a physicist from New Zealand, was among those leading the charge. He had already made significant contributions to the understanding of radioactivity and the discovery of the nucleus. His previous work set the stage for his most famous experiment. Rutherford's curiosity and determination drove him to challenge existing theories. He hypothesized that by bombarding atoms with high-energy particles, he could learn more about their internal structure. This hypothesis would soon lead to one of the most important experiments in the history of science. The plum pudding model, proposed by J.J. Thomson in 1904, described the atom's structure based on the electron's discovery. The atom was envisioned as a positively charged sphere with electrons embedded in it, like plums in a pudding. However, it had several shortcomings and did not explain certain experimental observations. This led to Rutherford's groundbreaking experiment, which revealed more about the atom. Rutherford's work showed that the plum pudding model was not accurate. Ernest Rutherford's hypothesis was bold and revolutionary. He proposed that the atom had a dense central core, which he called the nucleus. Rutherford believed that by bombarding atoms with high-energy alpha particles, he could probe their internal structure. Alpha particles are positively charged particles emitted by certain radioactive materials. Rutherford hypothesized that if he directed a stream of these particles at a thin sheet of nitrogen gas, some would pass through, while others would be deflected by the dense nucleus. This deflection would provide evidence of the nucleus's existence and offer insights into its properties. Rutherford's determination to challenge the accepted atomic models was a driving force behind his experiment. With this conviction, he set out to design an experiment that would prove his hypothesis and revolutionize the field of physics. Rutherford's experiment was meticulously designed to test his hypothesis about the atomic nucleus. He used a particle accelerator to direct a stream of alpha particles at a thin sheet of nitrogen gas. The setup included a detector to observe the behavior of the alpha particles as they interacted with the gas. As the alpha particles struck the gas, some passed through without any deflection, while others were scattered at various angles. The detector recorded the paths of these particles, providing valuable data about their interactions with the nitrogen atoms. Rutherford's team carefully analyzed the data, looking for patterns in the scattering of the alpha particles. They observed that while most alpha particles passed through the gas with little or no deflection, a small number were deflected at large angles. This unexpected result suggested that the alpha particles were encountering a dense, positively charged core within the atom. The meticulous design and careful execution of the experiment ensured that the results were reliable and reproducible. The moment of discovery was electrifying. As Rutherford and his team analyzed the data, they realized that the large-angle deflections of the alpha particles could only be explained by the presence of a dense, positively charged nucleus. This revelation confirmed Rutherford's hypothesis and provided the first direct evidence of the atomic nucleus. Rutherford's excitement was palpable. He knew that this discovery would have profound implications for our understanding of the atom and the nature of matter. The realization that atoms contained a dense core surrounded by a cloud of electrons was a monumental breakthrough. The discovery of the nucleus was a momentous occasion for the entire scientific community. It challenged the accepted models of the atom and opened up new avenues of research. The implications of this discovery were vast, paving the way for future advancements in nuclear physics and atomic energy. The immediate reactions to Rutherford's discovery were mixed. Within the scientific community, the revelation of the atomic nucleus was met with both excitement and skepticism. Some scientists were quick to recognize the significance of Rutherford's work, while others were hesitant to abandon the well-established plum pudding model. For those who embraced Rutherford's discovery, the implications were clear. The existence of the nucleus provided a new framework for understanding atomic structure and opened up possibilities for further research. Scientists began to explore the properties of the nucleus and the forces that held it together. However, not everyone was convinced. Some scientists were reluctant to accept the idea of a dense, positively charged nucleus, as it contradicted the prevailing theories of the time. Despite this initial resistance, the evidence in favor of the nuclear model continued to grow, eventually leading to widespread acceptance. The discovery also captured the public's imagination, sparking interest in the mysteries of the atomic world. The long-term impact of Rutherford's discovery was profound and far-reaching. It laid the foundation for the field of nuclear physics, which has since become a cornerstone of modern science. One of the most significant outcomes of Rutherford's work was the development of nuclear energy. By unlocking the secrets of the atomic nucleus, scientists were able to harness the immense energy stored within atoms. This led to the creation of nuclear power plants, which generate electricity through controlled nuclear reactions. Today, nuclear energy is a vital component of the global energy mix, providing a clean and efficient source of power. Rutherford's discovery also had a profound impact on medical science. The ability to manipulate atomic nuclei has led to the development of advanced diagnostic and therapeutic techniques, such as nuclear medicine and radiation therapy. These technologies have revolutionized the field of medicine, enabling doctors to diagnose and treat diseases with unprecedented precision and effectiveness. In addition to its scientific and technological implications, Rutherford's work has had a lasting impact on our understanding of the universe. Modern nuclear physics owes much to Rutherford's pioneering work. His discovery of the atomic nucleus set the stage for a host of advancements. Today, nuclear physics explores subatomic particles and nuclear reactions. Key research includes studying fundamental particles and nuclear fusion. Particle accelerators probe protons, neutrons, and other particles. This research has led to the discovery of new particles. Fusion could provide a nearly limitless source of energy. Inspired by Rutherford, scientists continue exploring nuclear reactions. The applications of Rutherford's discovery extend far beyond the realm of science. The ability to manipulate atomic nuclei has led to a host of technological innovations that have transformed our everyday lives. One of the most significant applications of nuclear physics is in the generation of electricity. Nuclear power plants use controlled nuclear reactions to produce heat, which is then used to generate electricity. This technology provides a reliable and efficient source of power, helping to meet the growing global demand for energy. In the field of medicine, nuclear physics has revolutionized diagnostic and therapeutic techniques. Nuclear medicine uses radioactive isotopes to diagnose and treat diseases, providing doctors with powerful tools to detect and combat illnesses. Radiation therapy, which uses high-energy radiation to target and destroy cancer cells, has become a cornerstone of cancer treatment. Nuclear physics also has applications in industry and technology, such as neutron activation analysis and gamma-ray spectroscopy. The impact of Rutherford's discovery is also evident in the field of national security, shaping global geopolitics. Ernest Rutherford's discovery of the atomic nucleus was a monumental achievement that forever changed our understanding of the atomic world. His groundbreaking experiment in 1917 provided the first direct evidence of the nucleus and laid the foundation for the field of nuclear physics. The impact of his work has been profound, leading to a host of scientific and technological advancements that continue to shape our world today. Rutherford's determination to challenge existing theories and seek out new answers serves as an inspiration to scientists and researchers everywhere. As we continue to explore the mysteries of the atomic world, we are building on the foundation laid by Rutherford and his pioneering work. We invite you to share your thoughts on Rutherford's discovery and its impact on science and technology. The story of Rutherford's discovery is just the beginning of a rich and complex field that continues to captivate and inspire. Now, I want to hear from you. What are your thoughts on atomic research? Do you think it's something we should continue to explore? Drop your opinions in the comments below. And if you're curious about the relationship between atomic science and nuclear energy, make sure to hit that like button and subscribe to our channel. Don't forget to press that bell icon for future updates and check out my other videos on space science and the wonders of the universe. Thanks for watching and see you next time.